Today we're going to talk about backwards incompatible tales. A lot of you may already know who I am, and don't be scared, right? I won't bite. I'm this guy on the internet. I do code reviews mostly, work for a company called Rove. We're consultants, which means that we make a lot of money and then waste it to go to conferences. Initially today I wanted to talk about wizards, because I have a weird fixation for Dungeons and Dragons lately. But effectively then I realized, okay, let's force the topic. Let's talk about modern wizards. Anybody know this person? Yeah. Right, this is Margaret Hamilton. She is a modern day magician, standing near the amount of code that she and her team wrote. And this person got us to do stuff that mages, even in the wildest stories, don't actually get to achieve. We managed to get to another planet, another thing in our solar system, let's call it like that. And I think that is amazing. That is what engineering allows us to do. Engineering allowed us to cure illnesses that, otherwise would kill you immediately, right? Stupid illnesses. We got bioengineering, healed, the end of the story. We got Takeshi's Castle. Okay, no, that's maybe not. Yeah, I still think this is a massive achievement. Takeshi's Castle is awesome if you don't have anything to do. So I think as engineers, if you want to use that word, we can achieve very, very big things. But on the other side, not everything goes nicely. And there are extreme cases of the opposite. So I'm taking an extreme case here. Does anybody know what this is? No, this is a 737-800. This is the previous one. So this plane has been flying for decades. I think it's as old as me, if not even more. So what happened recently, I don't know all the full details, so I'm just telling the top level of the story, so please don't sue me, But effectively, what happened is money. Airbus, the concurring company, said, the adversary company said, okay, we got a better plane, it uses less fuel, it does less noise, it brings more weight, does all these nice things, and you can save a lot of money. And people from Boeing said, okay, yeah, if those people are selling their planes, we're not going to sell our planes. Therefore, how am I going to afford my 5th Ferrari, or how I'm going to, buy my 3rd house, 4th house, 15th house, whatever. The idea is effectively that we need to make a better plane. We need to make it lighter, faster, use less fuel. It needs to be cooler, right? Proper rocket science. And what came out is, ta-da, this thing. This is a 737 MAX, which is a more recent version of the plane, and it achieves all of that stuff. So less money, less fuel, faster, more weight, and whatever. And effectively, they were like, yeah, money, cool, awesome. We managed to do what we wanted to do. And to do that, they had to introduce some system changes. Now, to change how this plane works, and again, this is proper rocket science. This is not PHP and building a website or a backend system for something. This is the actual rocket science when people say rocket science. So what happened is that in the MAX, they had this bigger engine. And in order to fit it, they had to move everything in the plane. You see everything shifted a bit, which means the aerodynamic was not quite the same. And with change comes uncertainty. And then you also have, business requirements and security requirements. So everyone is like bombing you from every side and telling you what to do. So there's a lot of pressure. And then under pressure, things go wrong, and you don't communicate changes because you're busy doing things. So let me be, I need to finish this. So you don't communicate everything you do, and then the systems break. So effectively, the reality is that this plane crashed already a couple times, and it crashed because they introduced a software system to mitigate a kind of a difference in how this plane maneuvers. So this plane tends to stall when it peaks up too much. So if the plane points up too much, it stalls. And stalling is that whoa sensation you feel in the plane when it's falling, kind of. If a plane like this stalls, it's a big problem. It's a massive plane. Once it stalls, it's falling. That's it. So what they did is they said, if the plane detects that it's going up too much at a too steep degree, it will point down. Now, due to an unfortunate set of combinations of technical failures, missing documentation, and effectively nobody knowing what was going on, a lot of people died here, okay? Shit happens. And this could have been avoided by just telling the pilots that there's a stupid button to shut this down. Press that button and you got full control over the plane. That's it. It was a documentation change that was not there. Because this was sold as it works exactly like before. No changes. It's exactly like the one before. And it is not. It's a different beast. So that is where our topic comes in. I realize I put quite a mood on this. I don't want to have everyone scared of writing software. Software is hard. It's better if you avoid it. But this is kind of to show the gravity of backward compatibility. For some things, it's stupid mistakes and you can fix them. Sometimes you don't even care, and sometimes people die. Right? This is kind of the scale where this affects everyone. So, short BC. And if you see in open source, we use this BC word a lot. In GitHub, you see that a lot. If you contributed to Symfony, Doctrine, whatever, and you wanted a new shiny feature, maybe some of you even sent in a patch, and then it got replied with, sorry, this breaks BC, we cannot do it, and it was closed. BC is really, really hard, I think. But the idea is that the new system must be able to operate with the pre-existing system without changes in how the previous system also works. So, BC breaks is when this goes wrong. So the previous system no longer works with the new system that got changed. The first BC break was when we moved from BC to AD. Thanks, Kat. That is a nice joke there. But so this is, I think, Life of Brian. But the other thing to understand is that BC breaks are normal. They will happen, and sometimes they have to happen because you have a change in what the system must do, right? We no longer sell this kind of ticket, or we no longer do this, or we do that thing because it brings more money, or we do that thing because it helps more people, instead of doing whatever we did before. So you have a change in how the system is supposed to work, and these changes will change the code and the system in general, the design of the system, and that design will no longer work under the previous assumptions. So the only constant is change. That's something that even the Greeks figured out. Heraclitus figured it out many thousand years ago. And effectively, this is true. You go into any company, and it's always a storm of everything changing all the time. Otherwise, we would be out of work. Unless you're only there for bug fixing, or you're in an enterprise. In an enterprise, you don't change things. You fight them through in meetings, and then the meeting gets applied maybe 3 years down the line, the results of the meeting. So let's look at PHP. Specifically, we look at PHP object-oriented programming. The reason is that we are used to it, so we will not look at functional programming today. So short for PHP object-oriented programming, POOP. Now, in POOP, we will look at changes in types. So what I want here is to do a quiz, a little quiz. So let's look at some simple BC breaks, and I want to see how many of you think they are BC breaks or not. So just say yes or no when you see them, all right? I'm going to ask about them. So we have a class in our system, and we remove it. Is this a BC break? Yes, it is a BC break because we can no longer reference the class. So now anything relying on this will be broken. Fair enough, easy. We have a class, and this class becomes abstract. Is this a BC break? Right? We can no longer use the new operator on this class. Fair enough. We have a class, and we make this class an interface. Is this a BC break? Also a BC break. We can no longer use new, and effectively you cannot clone it really. There's a lot of stuff that you can't really do. Oh, yes, interface became class. Sorry. Yeah. It's the same BC break, effectively. We have a method on a class, and we make that method abstract. Is this a BC break? Yeah. Now we have to implement it. So if we extend it by this, from this class, we now have to write it. We have a class, and we make it final. Yes. Don't do it after you deploy this, all right? Don't release and then make it final. Not just because I told you final is good. Just don't change it afterwards. Now you're going to have to stick with it. So effectively, now you cannot extend from it anymore, so you will get a fatal error. You have a method that becomes final. Is this a BC break? Yes. OK, fair enough. See, everyone got the gist. Gist? I don't know. Have no idea. We have a public property removed from a class. Is this a BC break? Yeah. We can no longer write to it. Well, you can write to it because it's PHP. Don't do it, please. I mean, fair enough. You have a protected property that is removed. Is this a BC break? Yeah. So any inheriting class can no longer rely on it. OK, let's do the private property. I remove a private property. Is this a BC break? It depends. It depends. The idea behind this is that, yes, of course, if you look at it like this, it is not a BC break. But is this class ever serialized? If it goes into the session or not, is it serialized? Is it ever used like that? Yeah, I mean, don't take reflection for BC breaks, as a good idea. But if you do this in a doctrine entity, it may go to the schema, and the schema is incompatible. So if you change it here without adapting the schema, it's also going to break things. So it is a risky change. And by the way, this comes from a problem in the language, which makes everything serializable by default. It should not allow serializing everything by default. I should declare serializable in order for things to be serialized. But PHP, yeah, that would be a BC break in PHP, yes. I add the property. Is this a BC break? It depends again. Is it serialized? If it's serialized, then you got a problem here, because now you got state that does not reflect the serialized state. The other thing that can happen, and I didn't tell you this, is that you can loop over objects. You can for each object, and that gives you all the property on the object. If you didn't know about it, please keep it like that. I did not tell you about this. We have an interface, and we add a method. Is this a BC break? I get this all the time. Oh, I want doctrine collection to also have this other method. Yeah, you can't do that. You're going to break a million packages downstream. Because now everyone having to implement this interface will have to add an implementation for this method. You have a class hello world, and you add a public method to it. Is this a BC break? Yes, no. OK, first of all, this class is an open class, which means that you can have an inheritance on it. You have a child class on it. So in practice, nobody considers this a BC break in the current open source world. But what can happen is something like this. You have a decorator that extends hello world and has this say something, and say something knows nothing about this new hello thing, right? this hello thing, this decorator does not know about it. Is the decorator broken or is it working? Unclear. You can also have another scenario, which is you have a private function declared with the same name in a child class, and now it breaks that way. It just fails to even run because it says private class, you can only make more open method on it. Sorry, a private method, and instead it should be a public method. So it is a bit of a stretch, but you see it can break, especially if you have a very large, very used package. This sort of stuff breaks a lot. Another thing is adding a class. Is this a BC break? Creating a new class. You're afraid to say no. Well, correct. Is it in a namespace? Okay, if it is your namespace and somebody declares classes in your namespace, I mean, you can just, send them a letter from your lawyer, That's what Oracle would do. But in PHP, this can happen. For example, the FN symbol. PHP 7.4 declares now that you have, I think it's 7.4, I'm not sure if it's 7.4 or 7. But 7.4 has short closures, and now anyone that declared a class or a function called FN can no longer do it. So the language broke BC here with everyone, which is fine, happens all the time, but it is a BC break. Fair enough. We have a class hello world that extends from hello, and we remove the parent class. Is this a BC break? Probably, yes. I mean, if hello has some API, we're breaking BC because now our hello world no longer has those methods. What can also happen is that hello is used as a type declaration, and it no longer passes type checks. So hello world no longer passes type checks for hello. What happens here? Hello world now extends hello. Is this a BC break? Yes. Depends. It is the same one as adding a method, though. The exact same. Adding a method, adding a property, serialization, all of these are possibly affected. We have a property, and we have a string property, and we make it nullable. Is this a BC break? Yes. So writing works as before, but reading from it may return null. And if you got null and you expected a string, then that's now your problem. The opposite. We have a nullable string, we make it non-nullable. BC break? Not. Okay, it is a BC break because reading works all the time now, but writing may break now. Before it accepted null, now it no longer does. So let's go to some definitions, because these rules, they are intuitively simple to understand, but in practice, there's rules behind it. Now, just very grossly simplified, we have a type A being covariant with type B if all the values of A are also values of B. This is what covariance means. So, in practice, A is covariant to B if A is included in B. So all of the A's are also B's. It's a subset. The opposite is also true. A is contravariant to B if all values of B are also values of A. So it's exactly the opposite. This means B is contained in A. That's what it means. So B must be a subset of A. So this is all there is to covariance and contravariance. What can happen is that you have simple types and complex types. You have a simple type such as just a number, but you can also have a complex type, which is a function that accepts a variable type that returns another type. This entire function is also a type. So types can be very small and very simple to understand, but can also be very large and very complicated. The rule still applies. The idea of BC breaks is that from a type perspective, anything you write that is new should accept everything you had before. Okay? So everything you had before must be covariant to anything you write afterwards. When it comes to state, mutable state in particular, it is neither. it is always invariant because state is readable and writable. Therefore, you need to have the exact same type in and out. You cannot make a smaller or larger set because as soon as you make a larger set, you're breaking reads, and as soon as you're making it smaller, you're breaking writes. Let's do more quizzes then. We have a class B extends A. This means that B is covariant to A. Okay? B is always included in A. Every B is also an A. The opposite is not true. Not every A is a B. Okay? We have a public function do something initially declared as A, and now we have public function do something, and now we have B. Is this a BC break? This is because we're making the set smaller. So now parameters cannot pass this type check anymore. The opposite. We have a type B extends A again, but now we make, from B we go to A in the type check. Is this a BC break? No. Well, okay, yes, it is correct. It depends, because I didn't make this final class. So if I change this, it breaks. There is a nice RFC in PHP, though, which is not implemented, but it's already accepted, which is the variance and contravariance. Basically, child classes should be able to declare wider types for parameters and smaller types for return types. It is pending an implementation, so Levy Morrison was working on it, but there's problems with the implementation, so it's still kind of in a limbo. Let's do it with return types. So we have a public function do something. Initially, it returns A, now it returns a B. Is this a BC break? No. It's a smaller set. And the opposite is a BC break or not? Yeah, this is a BC break, because now we are effectively making the set larger, so anyone calling this will get something unexpected. So there's this RFC called covariant and returns and contravariant parameters, which if you want and you have any knowledge about PHP internals, you can go and try helping with the implementation. So in POOP, effectively, it's all drilling down to variance and the Liskov substitution principle, where variance is about keeping those types compatible. Child classes should support parent classes types. And in LSP, the idea is that the child class should still kind of do what the parent type does. It should not do completely different things. That's the idea behind it. So if it is a logger, it should still log things. It shouldn't, print things to the output, or it shouldn't send emails. I mean, there's loggers that send emails. That's a bad idea, though. The idea is that you start seeing these smaller and bigger types, and you start seeing them everywhere, and that's really all there is to it. So your type X must fit into type Y, where type Y is the newer type. So, what about BC breaks in dependencies? You can have BC breaks in a library. So if you're relying on Zen Framework or Symfony or whatever, and you're inheriting from it, from any class, if the framework breaks compatibility, what will happen is that you will also have a BC break in your system. It is not this simple. There's also a lot of other stuff that can break, like parameters. You use a parameter that comes from the framework. That parameter changes definition radically. Now you also have a BC break. So there's a lot of BC breaks when you use this inheritance thing. So inheritance, I already talked about it. It is problematic. If you can avoid it, it's not really worth fighting the windmills here. Just don't go for it. If you can avoid it, avoid it. So make things final up front. It's fine. You can make them extensible later once you're sure that inheritance is okay. You can do things, make things internal. If it's stuff that is only an implementation detail of your system and it's not supposed to be used outside, and you know it, that's the hard part, you know it, you just mark it as internal, and nobody else should use it. And you can break BC there. I wrote a tool called, well, I and James wrote a tool called the Rove Backwards Incompatibility Check. Compatibility check, sorry. And all it does is you run it on a code base. So you run this thing, you install it, you run it, and you say, I want to check BC breaks starting from 262 to current master, and it will give you some output that maybe looks a bit confusing here, but effectively here I'm saying a method was removed, then there's another method that was removed, and here there's a more interesting one which says parameter association mapping of this particular method changed from being an array to a non-contravariant, and then this kind of object. So this will give you an idea of how badly you're breaking BC. So you can add this to your CI pipeline in your open source project or in your company project if you're declaring an API that you're giving to somebody else. And it will tell you whether there is a BC break. Whether that has to fail the build or not is up to you. That is your decision to take. The other kind of BC break that can happen, because let's be honest, these BC breaks that we talked so far are easy. These are the simple ones, because you look at a signature and kind of like clicks together. Okay, that's why. But there's a BC break type which is much harder to detect, which is a change in behavior. And for detecting those, you need to verify whether the expectations around it changed. For doing that, right now, there's no real machine that can tell you that. Not as far as I know. So you can have a BC break like this. You have an API endpoint, and it says, look, if this is a web user, then throw an exception, because people are not supposed to use this API endpoint when they come from the web. And suddenly what happens is that you have somebody using a cron job and sending a HTTP request to your front end, because that's the way they did it before, and that no longer works. BC break. Happens all the time. This is how we used to update some websites, like Joomla. You had an HTTP page that you would load in order to check if there were updates. So people would set up hooks. You set price. If the price is negative, throw an exception. You cannot have a negative price. Cool, makes maybe sense at that moment, but it happened to me that in code, in production, we changed this, and then an enterprise customer was no longer able to send negative invoices, which was something that was core to their process. Don't ask me why, I have no idea. You can have a change in just an integer. This could be, it was maybe 1 before, now it's 3, I don't know. But effectively, you got a file system abstraction, and now it's no longer listing just the files, and now is listing also directories. And you were relying on the fact that it was only listing files. Broken. There's no change in type. It just changes how it behaves effectively. This is also sneaky. You have an exception, and somebody comes in and says, yeah, but it's really hard to read which part is the fixed part of the exception and which part is a dynamic value introduced in the exception, so I'm going to put quotes there. And now some sysop somewhere designed a script that when the system crashes with a specific error message, it has to restart or something like that. System no longer restarts because the exception no longer matches your regular expression. And let's be honest, that's because it strings all the way down, right? That's why it fails. If we could represent this kind of change at a type level, it would be much safer. Changing in sorting, in priorities. We have list price categories, and we just change the sorting, and suddenly the second category is less important than the third one. Who knows who is relying on clicking on a certain link on the web page all the time? You can have a change in sorting. So sort prices, we realize that it's more effective for us to sort prices by the highest price first because it brings us more money, but maybe somebody was relying on that list and just fetching the first price to do some competition analysis maybe, I don't know. Broken here as well. So, behavioral tests, well, behavioral changes are detected by tests. So what you need to have is you need to have tests. You need to have tests. It's been a decade of people going around and telling other people to test. If you're not doing it, start doing it. If you're doing it, put effort in it because it is important. And I'm not saying test some things, I'm saying test everything. Like, there's no excuse for writing code that is untested and saying, this is not important, because BC breaks can happen pretty much everywhere. And you realize that there is a BC break once you have a test change. You see a test change that is not just making it nicer, you see a difference in how the test awaits things. That is where you know there is a BC break in the system. So, for example, in the doctrine stuff, if I see a test change, I just ask for a revert of the test, or the patch gets reverted. That's it. It's really, really easy. You see a test change, that patch will never make it through. Unless it's just because you make it nicer. But otherwise, it will not make it through. If you don't have tests, well, that is unacceptable. Don't do that. Tests are not optional anymore. They're not a decision anymore. It is being incompetent to not test, okay? So if you're not testing, bring it up with your boss because your company is doing incompetent work. That's how it is, sorry. Okay, and this is where tests pay off the most. So, other things you should do. Semantic versioning. Semantic versioning is not followed by every project. PHP itself is also not currently capable of following it. The idea is relatively simple. You have a versioning strategy for your product or whatever it is, in which you have this X, Y, Z, and the X means arg. It means ouch, something happened. Cool things happen in the Y, and the Z is just for fixes. So you are breaking things, you have new stuff, and you fixed bugs. That's how X, Y, Z works. So you only allow for BC breaks that are intentional, because you will have unintentional BC breaks. That will happen. You only allow for those in the X version. That's not always possible. As I said, PHP breaks compatibility all the time, for example, because it's such a large project. It has a lot of libraries. They upgrade an internal library used by PHP. It's going to change some flag somewhere, and somebody will not be able to list their files or something. Can happen. The other thing that can happen is that you fix a bug, and that bug was somebody else's feature, which is perfectly fine. So there's this XKCD about it, and this guy is complaining that, you know, I fixed this bug that when you press this key, then the CPU heats up. And this other person says, yeah, but when the CPU heats up was a scenario in which I would press the control key in Emacs. So please add a flag that allows me to use the bug again. So there is one thing that overrides all this BC break story, which is security releases. So if something may cause your system to be corrupted by malicious external entities, then a BC break is acceptable in a patch release, because a broken system is still better than a compromised system. If it doesn't run, but at least it doesn't leak data, that's still better than something that runs and leaks data. Okay? So breaking BC in general also is okay. You can do it. Don't be scared to do it. But what you need to do is you make it count, because every time you break BC, you are adding work for somebody else to fix. So you are generating work. You are thinking, oh yes, this is going to make my life so much easier, but you always have to compare that to how much people on the other side are having to work to reconciliate with your decisions here. So make it count. Make sure you announce it. Not like the Boeing people, right? You don't want people to have, critical scenarios there. But breaking BC is fine, you just need to tell people. So release notes, documentation, migration notes. You can also consider deprecating things first. So you say, okay, this endpoint is not going to be available in the next version because we decided that this is no longer something we do. So you give people time to prepare for a change. You can also do alpha, beta, and release candidates in which you are already breaking BC, but people can try it out, the courageous ones. They go and they try out your software and nothing works. Cool, it's an alpha release. We are expecting things to be broken, not just from a bug perspective. even just from an unexpected BC break. And the other thing is be there when you release. This applies to BC breaks, but this is also why I say don't deploy on Fridays. And I know there's a couple people that say, yeah, but I got the perfect CI/CD and setup, and we do Agile, and everyone is having their system looked at all the time. Cool, but shit happens. So if shit happens, it's better if you're there and not on vacation or not on the weekend. So releasing on Friday is pretty much in line with this. Don't do it. It's easy. That's it. You can do it, but if you have to work the weekend, then I told you so, you know. And you need to be ready to revert. So if there is a BC break and you realize it, you can decide now, do we want to keep it or do we want to revert it? Reverting a BC break is also a BC break because now your system broke twice in order to fix itself. So it is a decision. For example, I release a library and I realize 5 minutes later, oh, I broke BC. Cool. Do a new tag. It's going to be a patch release. You revert the BC break. The only reason why that's acceptable is because nobody's using it yet. But don't do it months later. You know, months later, just keep the BC, document it, maybe say sorry or whatever. That's fine. The other things you can and should do is teaching people about December matchers in your libraries. Use this kind of caret selector. This means anything above 123 before 200. Don't use anything like this. We did this in the early days of Composer, and we used a lot the dat star operator. This is the dat star, according to Sebastian Bergman. Don't do this, because your libraries are going to be there for a lot of time. So if you use the star operator, and there is a conflict in the dependencies, people are going to get your library from 7 years ago, right? Whereas they expected to get the one from this year. You can automate BC checks. I wrote a tool for it exactly because I was the bad guy. I was the want to fix guy. The person that says, no, sorry, we can't do that. So I'm the bad guy in most projects, and instead I wrote tools that basically tell people when something's wrong, because CI failures are still better than being shouted at. I'm not shouting at people, but this is how people perceive it. It's better to have a tool doing it, right? So there's no bad guy then. Right, to conclude, what do we say to the useless BC break? One fix. Thank you very much. So we got a few quick minutes for questions, if you have any. Yes. Okay, so the question is, somebody is using the library, a library that I wrote, and they're relying on a behavior that was not necessarily documented, kind of like that? Okay, so in practice, every observable behavior of a system is part of its API. What you can do is you can document what is internal or what is explicit API and make a clear boundary on that. Symfony does that, Doctrine does that. We just tell people what to not touch. But it is really, really hard to define where this boundary is. Projects like WordPress, for example, have a very, very large user base. So they cannot change even the tiniest detail because of so many people relying on all these observable behaviors that are not necessarily documented as explicit boundary. So at that point, it's the call of the maintainer. Do I want to break BC or not? But it is a hard question. So if you have those boundaries, it makes it easier. It's pretty much like a code of conduct, right? If you have it, it's easier to tell people when to shut up or not. If you don't have it, it's really hard to decide when to tell people to shut up or not. That's kind of the idea behind it. It's the same thing for an API. And it is a hard problem, because effectively you will make people angry for breaking BC, but it also is true that nobody's paying you for maintaining those projects. So in theory, since this is a weekend project, you just release a new major and go with it. Just make sure to make it a major version. But you will mess up. You will have mistakes on that. There will be BC breaks. There's no way in avoiding it. You can just do your best, though. Any other question? Cool. All right. Then, happy conferencing.